Okay, here we are with another video of equivalent series, and today we will be looking at what equivalent Young's modulus is. It comes under elasticity, right? So if I quickly recall the respective theory part, we know for a wire, right? For a wire, see, for a wire of area A and length L, right? Length L, we can write F over A equals Y times E over L. What is F over A? F over A is called stress, right? Stress. This is actually the tensile stress. Tensile means it acts along the length, acts parallel to length. Tensile stress, right? Tensile stress is tensile force over area, right? Perpendicular area. Y is Young's modulus. Y, Young's modulus. Young's modulus. It determines elasticity. The property of elasticity is determined by Young's modulus, right? E of L is called a strain, right? So in this case, that is called tensile strain, right? E is the extension. Extension is change of length from the natural length, from the original length or the natural length, extension. And L is natural length or the original length, right? That ratio is called strain. Okay, now let's see how equivalent Young's modulus works if wires are added, wires are connected in series and parallel combinations. First, let's see what happens in series combination, right? Series combination. See, let's say these two wires are connected in series combination. See, these two wires. Now, to you to see the wires properly, I add a denominator here, add the separator here, right? I add a separator here. See, and let's say a mass mg is suspended here. A mass mg is suspended here, right? And this is a wire with Young's modulus y1. This is a wire with Young's modulus y2, right? Let's consider their lengths and areas as A and L. Lengths and areas as A and L, right? And the equivalent wire to replace this, right? See, equivalent wire to replace this should be having the same mass, having the same weight, right? But here, original length of the system was L plus L2L. Then here, single-handedly, this should be having a length of 2L with an area A, because it should fit to the same gap. Fit to the same gap, length should be 2L, but area should be same A. So let's consider this as YE, equivalent Young's modulus as YE, right? As I explained in springs also, right? If joints are unbroken, which means joint is in an equilibrium, it is balanced. If the joint is balanced, now it is like this. This is mg, force on wire is also mg, force on this wire, first wire is, second wire is also mg, right? Then throughout that wire, same force is there. At this joint is unbroken, which means joint is at an equilibrium. Then if force on wire 2 is mg, force on wire 1 should also be mg. Otherwise, the joint is going to be broken. Therefore, this is the idea we can have, right? If this is mg, force on this wire is also mg, force on this wire is also mg, right? Which means forces are equal in series combination of wires, right? Keep that in mind. Forces are equal in series combination of wires, right? Now, according to the equation, what is our equation? Young's modulus equation. Our equation is F over A equals Y times E over L, right? Now, F is constant, isn't it? F is same. F is same. Area is also same, right? Lengths are also same. Sorry, length same and lengths of yang. Now, if I argue about, listen, if I argue about y and strain, now what happens is y is different, that is given. Then according to y, strain should be different. According to y, strain should be different. Therefore, E is going to be different. Therefore, E is different. Extensions are different. Now, I'll mark these extensions as, okay, I'll mark these extensions as E1 here and E2 here. And for this one equivalent, E equivalent here. Right? Right? Okay. Now, about the length also, I can build up an argument like this. Listen. About the length also, we have an argument from the strain. From the strain, we have an argument like this. Original length of this system was 2L. Original length. Original length of the system was 2L. Original length of the equivalent is also 2L. So therefore, definitely E is going to be different. Therefore, definitely E is going to be different. Right? We know when we are dealing with equivalence, we have to build up the argument for the different physical quantity. Different physical quantity. Now, different physical quantity is being extension. So I'm going to write the argument as extension of the equivalent is E1 plus E2. Because whatever happens for the system should be same for the single equivalent, right? Now, from this equation, let's subject E. See, we know, look at the board, F over A equals Y times E over L, no? Right? Now, from this, subject E, what is E? FL over IA. Correct. E is FL over IA. Now, easily, we can plug those values here. And force is here. Force is going to be mg here. Force is mg. Force is mg. So therefore, for EE, F is mg, L is 2L over YE A. For E1, same force mg, but length is L, Y1 A. For E2, same force mg, length is L, y is Y2 A. Right? See, now what happens? mg cancels, L2, L cancels, A2, A cancels. 2 over YE equals 1 over Y1 plus 1 over Y2. Right? Simplify. Then 2 over YE can be written as, here common denominator is Y1, Y2 over here Y1 plus Y2 comes. Subject YE. So YE equals 2Y1, Y2. 2Y1, Y2 over Y1 plus Y2. Right? This is the proved equation for equivalent Young's modulus when wires are in series combination. Now, if you can remember, right, this answer is very much similar to, very much comparative to the equivalents we have got in heat conductivity. Equivalent heat conductivity, very much similar. Right? And again, compare this answer with equivalent resistivity as well. Right? So, this is what happens in series combination. Now, let's see what happens in parallel combination of wires. Parallel combination. Parallel combination. Right. Now, let's consider these two wires which are connected parallelly. Two wires here, two wires. And for the wires, this mass mg is suspended. Right? These two are two wires. Two wires. Right. So let's say this is y1, this wire is y2. Right? Lengths of both of them are L and areas are A. Right? So equivalent, which is going to replace the system, should also be having a same length L. Same length L. Right? Same length L. But areas of wires were A each. A each. Then total area of the equivalent should be not A, that is 2A. A plus A, 2A. So therefore, say this is Y equivalent YE. This should be length is same. Length is same L, but area is now 2A. L and 2A. Right. Again, argue with the equation. Argue with the equation. According to the equation, F over A equals Y times E over L. No? Right. Now, A is A is 2A and 2A, which means constant. A is constant. E. Now here, can you see both wires are going to extend simultaneously, similarly, when they are connected in parallel combination, because both goes down together. So therefore, E is also same. And here also, then it should be same. E is also same, right? Lengths are also same. Therefore, with different Y, now force is going to affect. If Y is different, forces are different, which means there are going to be two forces on each wire. So let me label these two forces as F1 and F2. Let me mark these forces, label these two forces as F1 and F2, right? And force on this wire as force on equivalent Fe. Force on equivalent Fe, right? Then argue with the different physical quantity. We can say Fe equals F1 plus F2, isn't it? Fe equals F1 plus F2. Now, from this equation, get the substitution. We know F over A equals Y times E over L, right? Which means F can be written as YA E over L. F is YA E over L, right? So substitute here, plug values here, plug values here, plug values here. Fe should be YE, area is 2A, same E over L. F1, Y1, A, E over L. And F2, Y2, same area, A, L, sorry, E, same E over L, right? See, E cancels, A cancels, L2, A cancels, right? 2YE equals Y1 plus Y2. We need YE equals Y1 plus Y2 over 2. This is the equivalent Young's modulus when wires are in parallel combination, right? So again, compare these answers with the resultant values. The equivalent values we have got for resistivity and heat conductivity, right? Same patterns are there. So you can identify the pattern, right? So this is what happens for Young's modulus in series and parallel combinations, right? So I hope it's also clear. If there's any questions, you can add a comment here to this video, right? So with this video, I'm going to wind up. I'm going to finish off this video series of equivalents. Here we have discussed all 7 equivalents we have in our syllabus, aerial physics. All 7 equivalents I have discussed here, right? And I'll be uploading these videos as separate videos for you to watch videos separately as different equivalents, right? So I hope you have got something from the series. If you didn't know this, go through and familiar yourself and be comfortable with these things, because all 7 equivalents are going to be very important. They are playing roles in our syllabus, all the equivalents, right? Okay, then we'll stop the video from here. See you all again with another video, right? Goodbye. Study hard.